go over a few of these word problems. So a lot of things, as David discovered, can be modeled with quadratic equations. This particular quadratic equation, does anyone know what the acceleration due to gravity is? 9.8 meters per second, but it's also 32 feet per second squared. Okay? And this number right here, this 16 is half of that. So if a kangaroo or anything for that matter goes up, you're launched with some initial, in this case it looks like this guy is jumping up at an initial, you don't have to know where these numbers come from, but he's jumping up with an initial velocity of 16 feet per second from a height of 5 feet. Then this is acceleration, which is trying to pull him down. And what you have over time, if you were to graph it, okay, what type of quadratic function does this, or what type of function does this make? What type of function does it make? If it's got a squared in it, it makes a parabola. It's a quadratic function, right? And he starts here. So you could figure out kind of what this looks like by, say I were to plug in 0. So this is 0. This is time over here, okay? And at time 0, how high is my kangaroo? How high is my kangaroo? Jessica?
0.
0, right? No, he's not. 5. He's at 5.
All right.
Right? When you plug in 0 in here, you get out 5, right? So 0, 5 is where it starts. You give yourself a pat on the back there, David. Okay. And then, and then, does this make it upside down or right side up parabola? Upside down, right? And so the maximum height is going to occur, and this is when he hits the ground. So he's jumping off something which is at a start of 5 feet. He goes up to some maximum height, and then eventually he's going to hit the ground. So what they're asking, what is the maximum height? So what they're asking you is, for all they're really asking you for this, in this case, is the vertex. So let's find the vertex. How do I find the vertex of that? You should know this from the stuff we've done already. Sophie?
Negative b.
Yep. X equals negative b over 2a. So in this case, that's going to be negative 16 divided by 2 times negative 16. Whoops. Hard time writing. Which gives you a positive number. What does that give you? What's negative 16 divided by negative 32? 2. 1/2. Look at right. It's right. That's 1/2. So, which question does that answer? Is that the maximum height, or is that when is the maximum height reached? Which question does that answer? Go ahead, just. That's when, right? That's the x value, or in this case, it's the t value, right? That gives you the maximum height, right? So this time, at 1/2 of a second, that's when the maximum height is reached. Okay? How would I figure out what that maximum height is? Not that hard. How do I figure out the maximum height? Go ahead, David.
Like you do the parentheses.
Yeah, you just plug that number into the parentheses, right? So if I do that, I get negative 16 times 1/2 squared plus 16 times 1/2 plus 5. So this is the answer to question A, okay? And so what do we get? What's 1/2 squared? I'm going to do some mental math here. What's 1/2 squared? Do it as a fraction, not as a decimal. What's 1 times 1?
1.
What's 2 times 2? 4. What's 1/4 of 16? Negative, right? So this number right here turns into a negative 4. What's 1/2 of 16 here? 8 plus 5. right? Which gives you -4 plus 8, which is 4 plus 5 gives you, hello, 9 feet is his maximum height. So at 1/2 seconds, 9 feet, that's when he, what is the maximum height? 9 feet. When is the maximum height reached? 1/2 seconds. Okay? So this answer is right there. Is that hard? Piece of cake, right? Okay, so maybe we should have you guys go get one of my newfangled whiteboards and try the next one. I think that's a good idea. Okay? So, and there's markers in there. The only thing I don't have is erasers. Okay? They're tiny, I know, but
Justin,
yes.
So there's also
Like write down numbers, especially in word problems. If you're on some kind of formal test or something, and on my test I'll take off points if you don't say what the things mean. So negative b over 2a in this case is going to be negative 1.6, which makes it positive 1.6, right? 2a is 0.2, and 1.6 divided by 0.2 makes 8. And that's the answer to this question. It's not really the answer. In the 8th month, what is the 8th month? What month? So make sure you answer the question. What is the 8th month? August, okay? So you have to say 8th month, which is August, okay? And then what is the minimum how do you say that word?
precipitation.
Precipitation. You plug that 8 in. So watch, I saw a lot of you didn't get this right, so I want to 8 squared minus 1.6 times 8 plus 7, right? And so this squared is 64 times 0.1 makes 6.4. I'm doing this in my head. This is negative number, let's see, 3.2, 6.4, 12.8, is that right? 12.8? Yep. And this is plus 7. And then you just put those together, so you get 6.4. Wait, what happened? Yeah, negative 6.4 plus 7 makes positive 0.6. What is the minimum precipitation? 0.6 inches, okay? Just to show you, if I did graph this one, okay, in this case, you're looking for a minimum, not a maximum. So in this case, if I plug in 0, I get out 7. This graph looks like this, right? Kind of goes like this. So you're looking for this point down here. And the other one, when it's at a bottom point, you're looking for when the curve is, they call that concave up. You're looking for a minimum. When the curve is concave down like that, you're looking for a maximum. Okay? Let's look at the next one. And the next one, where'd it go? Where'd it go? It went here? Here? There it is. No, here. Here. Where did it go? Here it went. Here it went? There we go. Number 3. Projectiles launch. So in this one, I just want to help you set it up a little bit, because you don't always, this might be getting at what David asked, okay? You do not always have to solve it using negative b over 2a, okay? Depending on the situation, depending what the equation looks like. I would kind of draw a little graph to see what you're talking about. A projectile is launched vertically upward from the ground level at an initial velocity of 288 feet per second. That's that, okay? This is gravity again, pulling that rocket back down, where h is the height in feet, and c is the number of seconds after it's launched. What is the height that this rocket's going to start at? If I plug in 0, I get out 0, right? So it's going to go up, and it's going to go some of you guys doing this in science class, right? Shooting a little ball with a catapult. Did some of you guys do that? Maybe it was in next year's. Yeah.
I
Yeah,
watched
okay.
Toy Talk.
You did, right. So in any case, well, stop that. So in any case, this is what it looks like, and again, you're looking for this point up here. So you could use negative b over 2a if you want to, okay? But there's actually, and this one's a little different because it says find the number of I was wrong. Find the number of seconds until the projectile hits the ground. So where is it going to hit the ground? Where is it going to hit the ground? Yes, ma'am?
Where h equals 0?
Yeah, you're going to hit the ground right here, right? So really you're looking for this point. So what you do in this case is you set it up as negative 16t squared plus 288t equals 0, okay? And you could use negative b over 2a, but there's actually a better way to do that. Does, who knows what number goes into both 16 and 288? 16 actually goes into 288. Anyone know how many times? No, does it, is it 16? No, it's 18 times. So what you could do here is pull outside of your parentheses a negative 16t. I'm going to factor this, okay? Negative 16t times what gives you negative 16t squared? T, okay? Then you put a minus here, 18. Do you guys know why it's minus? Right, because if I factor out a negative 16, negative times a negative gives you a positive 288. Then I do my thing with my little squiggly line, okay? And I got two answers. This answer gives you negative 16t equals 0, t equals 0. This one gives you t equals what? T equals what? T equals what? T minus 18 equals 0. What's t? 18. Okay? So this corresponds to this point over here, and this corresponds, this is when it's launched. These are the two times when your rocket has a height of 0. One right when it's launched, and one when it hits the ground. So that's the number, that's this answer, 18 seconds. Okay, I guess we'll try the next one. Find the number of seconds until the projectile is 1280 feet above the ground. Uh-oh, that's kind of hard. Anyone have any ideas how I do that? Yes, ma'am.
You plug in 1,280 for h.
Right, okay. So for that one, instead of putting 0 here, they're asking you, when is this rocket at a height of 1,280? So what they want to know is when, it might be two spots, it might just be up here, but we're going to see, okay? So what you do for part B is you say negative 16t squared plus 288t equals 1280, okay? Then I want to bring everything on the right side. So when I do that, I get negative 16t squared plus 288t minus 1280 equals 0. Okay? Negative b over 2a. Is that what I'm trying to find? No. I'm trying to see where this thing's equal to 0. So I'm not looking for the vertex, right? I'm looking for when it's equal to 0. So I either have to try to factor this. Does 16 go into there?
Yeah.
It does. Okay. I either have to factor it, or I have to use quadratic formula. What not? So 16, negative 16, I could pull outside. T squared. We already know that 16 goes in 288. 18 times, my Moby board is acting, 18t. And I also know that 16 goes in here, how many times? 80 times? 80 times, okay? So you would have to do, like, you'd have to divide this into this. If I didn't know how to factor that, I could use quadratic formula, and you get the right answer, okay? So now what's nice about this is this factors, okay? So I have negative 16 times, so t, what two numbers multiply to 80 and add to negative 18? Anyone else? Negative 10 and negative 8, okay? Negative 8. And so then you have to figure out where these two things are equal to 0. What's going to give you this? What's going to make this equal to 0? T equals what? 10. What's going to make this equal to 0?
8.
8. Okay? So in actuality, there's two places, right? There's actually two places where this thing is, where it's going to be 1,280 feet, right? So if you look at it graphically, if this is 1,280 feet, one place it's going to cross is right here at 8 seconds, and the other place is 10 seconds. So there's two answers to that problem. Yes, ma'am?
So, since 9 is between 8 and 10, could we assume that the vertex is at 9 something?
Yep. Just because it's symmetric, right? Because it's 0, 0 here, right? If this started somewhere other than 0, then you couldn't do that. You know what I mean? So if it were like lopsided. So what Jessica said, could I assume that the vertex is halfway in between? Yes, you could. Good question. Did I restart recording? I'm still recording. You ready to do the next one? I'm going to let you guys solve the next one, but I'm going to help you set it up. What?
So I didn't know we didn't have homework, so I tried the homework, and then it said that we needed to solve it to like solve the square or something.
Completing the square?
Yeah, use that method.
Solve however you want. On these problems, I don't care how you solve it, okay?
Did we have homework last week?
No.
Oh, really?
Well,
Why do we need this equation if we can use later?
because like this one works very nicely for factoring, right? This factors very nicely. But if it did not factor, right, then you would have to use either completing the square or you'd have to use a quadratic formula, okay, to solve it, right? And sometimes, like this one, I just guessed that 16 went in here, but because it was a, an example problem, and usually they make those work out nicely. But a lot of times things don't factor, and then you got to use quadratic formula. Okay? But different methods, like if you see something that's in this form, you can either try factoring it, or you can use quadratic. I mean, there's a lot of different. Sometimes you're looking for the vertex. Sometimes you're looking for where it's equal to 0. Okay, so it kind of depends on the situation. All right. I'm going to do the last one or help you set up the last one. And then you have five problems to do for homework. You're going to finish this one after I set it up for you. Okay? So this, you have probably seen a problem like this every year. Okay? These ones come up again and again. I bet you saw this on the park test or something like it. Those of you who took the park test. A farmer has, am I recording? Am I recording? Yes, I'm recording. So a farmer has 60 meters of fencing to surround a rectangular field for his cattle. One side of the field touches a river. What is the maximum area that the dimensions of the field should be? Okay, so what you do is you draw a picture of a field, a rectangular field. Woo! Don't you wish you had a Moby board? I bet you do. Okay. So he has 60 feet of fencing. They're asking you to find the area. So say I call this side X and this side X. How much do I have left for the other two sides? I have 60 feet altogether. This is the hard part, okay? So what you do is you let x equal one side, okay? It's a rectangular field. Altogether I have 60, right? So I could call this y, okay? If I want to, but we're not going to call it y because I want to show you why I call it what I call it, okay? So if I call this y, then I know that the perimeter is 2x plus 2y. What's 2x plus 2y? What's 2x plus 2y? What is that? Has to equal 60. You guys understand that part? Yes? Okay. So now I'm going to solve this little equation for y. I'm going to divide both sides, or first I'm going to subtract 2x from both sides. Subtract 2x, subtract 2x, and I get 2y equals 60 minus 2x. How do I get y by itself? Divide everything by 2. So I'm going to divide this by 2, this by 2, and this by 2, and that gives me y equals 60 divided by 2 is what? 30. Negative 2x divided by 2 is what? Minus x. So this side over here is 30 minus x. How do I find the area of something? You're trying to maximize the area. How do I find the area of something? What times what? X times y, or length times width. So in this case, what I'm going to do is I'm going to multiply x times 30 minus x. What shape is this going to make? If I multiply this out, I get 30 minus x squared. What shape is it going to make? What shape? What shape does 30x minus x squared make? It makes a parabola. Right side up or upside down? Minus x squared. It's going to make an upside down parabola, okay? And this is this is the area. It's not y, okay? But this is x. What they want to know is what should be the dimensions, okay? So if I have an equation where I'm trying to find out where x times 30 minus x is equal to, I really want to find this high point up here. But kind of what Jessica was getting at in the last problem, where's the high point going to occur? In the middle of these two things, right? What is this point right here? Look at this equation. If I said that equals 0, what gives me this is equal to, what two values give me this is equal to 0? 0 and what else? Not negative 30. Positive 30, right? So this is the point 30, 0. This is the point 0, 0. What's halfway in between? 15. What? I wrote 12. Okay? I don't know why I wrote 12. But 15 goes right here. And if x is 15, what's y? 30 minus 15. What's that? 15. So this point right here is, so what is the maximum area? What should the dimensions be? The dimension should be 15 by 15. What's 15 times 15? What's 15 times 15? Chase, what's 15 times 15? You guys don't know what 15 times 15 is? 225. Okay? 225. That is the biggest area you can make out of this fence. Okay? So that's a complicated problem, right? So first, I could have also looked at this equation, 30 minus x squared, and found the vertex. Negative b would have been negative, whoops, I screwed up. That would be 30x, no, that's right. 30x times 30 minus x squared I would have got, negative b would have been, it's 30x minus x squared. Negative b would have been negative 30, and 2a would have been negative 2, and I would have gotten 15 out. See that? That would have given me the x coordinate of the vertex. Okay? I think you could do some of those on your own. Okay? I don't know. You might need some help, but in the book there's very clear examples. I gave you some good examples. Do what you can do for homework. Okay? Your homework is in your book. There's only 5 problems. Okay? Okay, 7, 8, 9. Oh, that's 6 problems. Okay? Homework. Homework. Okay? Page 5, 5, 9, 7 through 12. Okay? Show work. If you just write down the answer to the problem, you will get no